Hello, students. So, I am still very sick at the moment, and so if my voice is a bit croaky or if I make some little mistakes along the way, I hope you'll forgive me. I've already made a couple in previous videos. So, today's chapter is multiplying and dividing with expressions. You can find that in your maths textbook on this page here for you. But basically, the idea is to convert expressions with multiplication and division symbols into proper algebraic expressions, which means we are trying to learn the skill where these symbols are not used in the finished expression. An expression, I suppose, is kind of like maybe think of it like a sentence in English. So here's like a little maths sentence here, or phrase, if you will. Here's another maths little sentence or expression, and here is the algebraic form of it. So we basically want to be able to write things like that and like that. We will step you through the process, of course. So I've quickly grabbed these notes from a previous class some years ago. So I think the idea here was that Mathilda the Turtle, she really likes simplifying. So she much prefers this over this format here. So I think that's why the little turtle is over there. Okay, so what's the purpose of, doing this conversion with the time symbol and the division symbol? Well, the idea is that in mathematics, particularly algebra, we often use the letter X. It's common in a lot of solving equations, so we don't want to get the letter X confused with the multiplication symbol. To get around this issue, we have other ways of implying a multiplication is happening. And the system basically is, if you have a number next to a pronumeral or a letter or I think we also call them a variable. So basically a letter of the alphabet, if it's next to something like a number, then there's actually a time symbol right in between. Okay, so when I say 5k, I actually mean 5 times k. Easy. Here I've got xy, so this is a classic example where I don't want to get the time symbol confused with the x letter of the alphabet. So it means x times the y. When we have side by side, it can also occur when there's a bracket next to it. So here's a coefficient. A coefficient, it's these numbers in front of a letter. So I've got a coefficient here right in front of some brackets here. And I've just given you the rule here that there's no times or plus or something written next to it. So it's actually a time symbol right there. And because of this special case that I've drawn here, they're all multiplied. So these two are side by side to each other. So hence it's a times b as well. So when I, expand this whole thing out, I get the 2 times the a times the b, and so on. Just a quick reminder, like if you're unfamiliar, a letter, I've been using the word letter, it's just a bit more obvious when I say that out loud. But if I want to get technical, you should get used to the terminology of a pronumeral or a variable. That's what the letters are. The other word you need to learn is coefficient, and that'll be these things when there's a number in front of a letter. And that could be things like -3, for example. That negative sign is part of that coefficient. Okay, so how are we going to put this into action? So usually there'll be a question on the test, probably the first page, where it's super basic and easy. It says, write the following without using multiplication or division symbols. So if I was to rewrite this, it would be 2b5. Now, that kind of looks a bit strange, and I picked this example for a reason, is that we often want to have our answer as simple as possible. So I know that from this, when I expand them all out, sorry, I can actually change the order here slightly. That is perfectly allowed, and I do have an example down below. Let me just come back to this in a second. I probably should have put this earlier. So multiplication, 2 times 3 times 5, I did the calculation, I got 30. If I shuffle the sequence, so it's now 5 times 2 times 3, this is the second row here, I still get 30. So what's the rule happening here? It turns out when you have a chain of numbers that are all multiplied into one another, then that particular chain can be shuffled in any order you like. And that's useful because we often will do that in algebra. We will shuffle the order. So since all these three items are multiplied against each other in a chain, I can change the sequence like so. Now that I've changed the sequence, I have found a more simplified answer. I can do this bit and actually get a singular number, a singular coefficient of 10, and then I carry down the b. So I'm going to put the b side by side against here to imply that there's a multiplication between the two. So there's a trick. Next bit. Fractions are the algebra form of division. So you're familiar with things like that, maybe not the letter, for example, but you're familiar with like 2 divided by 3. Well, we are going to basically try to adopt using fraction form from here to the end of high school. It'll be the standard practice almost all the time, because particularly with algebra. So the sooner you get that part of your repertoire or your default, then the better. So just some quick examples. We've got, write the following without using any multiplication or division symbols. So I've got 2 questions here. One's a bit more interesting than the other one. So if I was to write this, it has to be a fraction, right? So something goes up here, something goes there. But which one goes on top? Which one goes on bottom? Well, because that's the only thing that really goes wrong on this particular question on the exams. Sometimes the students will have them the wrong way around on the fraction. And if it helps you, I like to think of this, I think vinculum, which is this symbol, this part of the division symbol. I want you to imagine this is like a bunk bed. And when you go to school camp, the first person rushes in and goes, shotgun, I've got top bunk. And then the person who's late to the party is like, oh, fine, I'll go in the bottom. So that might help you remember which one goes on the top. The first number, so if I rewind, the first number that appears in the sentence, in the expression, goes on the top bunk. And then the second thing that appears on the other side has to live on the bottom bunk. So that one there is done. That's what about this one? This is a bit more interesting. Here I've got some brackets. That means whenever I see brackets, I want to try to treat this as a singular group or a singular unit. So what we're basically saying here is that the whole green thing gets shotgun and lives on top of that fraction sign, and this has to live on the bottom of that fraction sign. So this will be 2x plus y all over 5. Right, so just keep that in mind. Whenever you see brackets, I want you to treat it like a giant, like a bag of things, or a group. All right, next one. We got letters are often placed after the coefficients. Okay, and we also list them alphabetically. So for example, I've got C times 2 times B, and Mathilda has gone to work here. She's grabbed the number 2, which was here, and she's moving it to the front of that sequence. And she's also written them alphabetically. These 2 letters are in alphabetical order. So what does that look like in reality? Well, we would typically write that for XYZ, not this one, where it's X4ZY. That just looks really strange. If you did this on an exam, when I say we, I mean maths people, maths teachers, etc. We would understand what you meant, but it's not standard practice, and it looks really weird. It's like people who pull up their pants way too high. They're not wrong, they're still wearing pants, but it looks really weird. So to make it look normal, we put our numbers in front, and we put the letters in alphabetical sequence. And we can do that because we already ran over this rule here. When everything's multiplied against one another, it won't matter if you shuffle the order because the answer will be the same. So if I've got this little scenario, b times 4 times a, well, the number should be in the front, and then the letters should be alphabetical. And because these are all multiplications in between them, I have put them all side by side. Easy. Okay, another little side note, as this is mentioned in the book, brackets don't matter if only multiplication is being used. So if I've got 2 times 5, and then there's a bracket, then this really is telling us it is 2 times 5 times 3. Because you recall the rule here is that when the things are side by side against a bracket, then that usually implies a multiplication is happening. This is not to be confused with, oh, you can also rewrite this one entirely differently if you like. So it'll be the same answer as if I had done 2, 5, x3. This will still be the same answer. So all of these 3 things together are the same results if you were to punch it into a calculator. I don't want you to get confused when there's not the case with every bracket. So if it's not only multiplication, so if I've got 2 plus 5 brackets 3, that's not going to be the same thing as 2 plus 5 times 3. That's not the same thing. And that will be a different lesson down the road. So just keep in mind that if there's a plus sign inside of your bracket like this, or there might be a subtraction sign, then you can't use this trick. You would have to use something known as the distribution law or distributive law, which I think we'll do later on in the year. Okay, this will be the last sort of demonstration bit. There's a challenge one down here as well. But when it comes to division, so we've learned how to simplify here, where we change the order. I don't know if you remember this one, where we changed the order around so that we could get the 2 and a 5 together to make the 10. It's nice and simple. This one here, the idea is that you can simplify the pronumerals in a fraction the same way we simplify coefficients in fractions. So let's just do a quick recap of what I'm getting at here. So if I've got 6 over 8, you recall the process where I can scale the fraction up or down. If I scale it down, I'm simplifying, so I can divide the top with a 2, divide the bottom with a 2, and I should get 3 over 4. So you're familiar with that process. Well, what if I have let me put a new example. What if I have 3x over 6x? Well, you're familiar with how we can simplify these numbers here, which are now behaving like coefficients. So I could divide the top with a 3 and divide the bottom with a 3. Okay, and that would give us just a 1 up here. And that just becomes an x. And what I meant there is that in algebra, the number 1, if it's a multiplier, it's invisible. It's an implied. So there's invisible 1 in front here, but there's no point. There's only one of these x's. If there's more than one x, then we actually put in the coefficients in front. If there's only one of them, this number 1 is just invisible. So if I divide them both with 3, I would get 2x in the bottom. Where can I go any further? Yes, I can. Why can't I divide the top and bottom by an x? Because remember, pronumerals are just they're just placeholders for numbers for later on. Now, because I've used the same letter, top and bottom, whatever this number is supposed to be, it's the same number. So if I divide top and bottom by x itself, it's like I'm eliminating that and I'm eliminating that. Well, technically this now becomes a 1 because x divided by x is just 1. Any number divided by itself is 1. So the result is 1/2 when we're finished. So I'm going to use this process here. Maybe it'll get clearer to you why this works if I expand it out. So let's just translate this for a second. Normally, I wouldn't go to this step that I'm about to show you. I would just go straight down to here, which you'll see in a second. So if I expand this one out, what I'm really saying is this. Okay, so this is the expanded format. Now you can see that we've got a bunch of things that are multiplied. Surely we can simplify these coefficients by dividing by the largest factor they have in common, which would be dividing with 2. So I could divide them both with 2, top and bottom. Okay, so if I divide this with a 2, this just becomes a 1. If I divide this with a 2, this becomes a 2. So we're getting better. I could also divide top and bottom by any common coefficients. So I have a common pronumerals or letters. I can see the letter B appears top and bottom. It is times B and times B on the top and bottom. So surely I could just also divide by B, divide by B. If I did so, B divide by B would just give me a 1. So this is times 1. And B divided by B would also give me a 1. So what is our result here? 2 times A times 1. That's 2A. On the bottom of our fraction here, 1 times 1 times C. That's just C. Remember, the 1 is invisible. Now that is quite hectic and messy, I now understand, so let me just rewind. Here's how I'd normally do it. This is just more time efficient. Okay. What you generally do is that if there is a pronumeral that appears top and bottom, then you can basically cross them out when you've divided them both. Here with the 4 and the 2, well, the same as usual. So if I divided that with the 2, I get 2 remaining. Divide that with the 2, I just get a 1. In this occasion here, I don't need to write the number 1 because it's just going to be one copy of C. I could put a 1 there if you like, just to keep things clean. And I could put a 1 here if you want as well. So now once I'm finished, it's going to be 2A times 1, which is just 2A. 1 times 1 times C, which is just C. Okay, now that you've got the main idea, you can do these basic ones down here. So we've got the 5 and the 9 don't have any factors in common, so I can't simplify anything further from there. But I've got the letter pronumeral showing up top and bottom. So I can divide that and I can divide that, and the answer should be 5 over 9. Remember, A divided by A is a 1, so 5 times 1 is 5. A divided by A here becomes a 1 as well, so 9 times 1 gives me 9. Let me just rewind. If I did this one, I can see the letter A appears top and bottom, so it's almost like I can just sort of cross it out and pretend it doesn't exist. The 2 and the 5 don't share anything in common in terms of factors, so that's just going to be left as it is. So I'm left with 2B over 5. I want to challenge you now. Now, this one I might lose some of you, but this type of question, which will show up on the end of your exam paper, it's kind of scary. I can't guarantee, but it used to appear on the exam somewhere in the back, something just like this. We are going to use the same tricks here. In here, all I've done to make life hard is that there's a lot more letters, and I've also introduced a power. So if we expand this one out, if you're ever in doubt, you can also expand them out, and then I think you will see where you can proceed from there onwards. Now that I've expanded it out, now this portion here is the A squared. When you have squared, it means A times against itself, and there is 1 and 2 of them. So now that I've done that, now we're basically going to use the same procedures as before. Can I simplify the coefficients at the front of the line? I can divide them both with a 12. So if I did that, 36 divided by 12, I think, is 3. 12 divided by 12 is a 1. Already we're looking better. Let's go looking for any letters that they share top and bottom. So let me just get rid of the yellow. Do we have any that match? I can see the letter A appears a few times. I can also see the letter Change to a yellow. I can see the letter B also appears. So the process here is I can divide top and bottom by the letter B. So that would basically turn into a 1. That would turn into a 1. So remember, it's a chain of things multiplied together, so I can put a 1 here if you really want me to. With the purple ones, I can only divide top and bottom by a singular A. I can't do it repeatedly, so I can divide that by A. I should only have one of them remaining, so there should be a 1. Divide this with an A. That'll become a 1 as well. So now if we look at what's remaining, I know it's really messy right now, I hope you'll forgive me. 3 times A times 1 gives me 3A. 1 times 1 times 1 times C gives me C in the bottom, and we're finished. Look, you can make some of these to practice for yourself, or if you've got a tutor, they can make a bunch up. But essentially, you can pick something that is something interesting as your coefficient at the front of the line, and you can put a bunch of these letters where some of them are common and some of them are not in common. So for example, the letter C doesn't have anybody that matches it in the top row. And you can introduce powers like this number up here, powers like this up here. Don't go crazy, don't put like 12 to the power of 12, otherwise you'll be there for days. But you can make some of those up for yourself to practice on. I'll end the video here and quickly upload it before the lesson. Good luck, everybody. You've basically learned all of my tricks for this chapter.